And we are live on the Voice of the Cape Facebook and YouTube platforms for today's edition of the Matric Revision Programme. And today the subject is geography, and the paper is paper 1 on climatology, that is with regards to anticyclones, valley and city climates. Our guest facilitator for this session is Aalia Kara. She is an educator at Futures Academy Online High School, and in the description of today's lesson is a link to some resources provided by Futures Academy Online High School. But assalamu alaikum to you, Alia, and welcome.
Assalamu alaikum. How are you, Kanita?
I'm very well, Alhamdulillah. Today being the second session with you on geography, I know that there was quite a lot that I learned personally, but I'm sure for our grade students preparing for the exams, these sessions are very beneficial. So we do encourage our viewers, if you know of anyone who can benefit, any learner who can benefit from these sessions, please do like and share. You never know who could obviously benefit from these sessions. So, Alia, without further delay, I hand over to you to commence.
Shukran so much, Kanita. Yes, definitely. Please do share the link. It is a good background understanding of the sections. I have tried as much as possible to condense the sections where I provide you only with essential information. If you do have any comments, you do want to actually mention something, please do so in the comment section, and I will try as much as possible to get back to you as soon as I can. So today's lesson is on anticyclones. It is on valley climates. It is on city climates as well. Also, we are touching on traveling disturbances from your anticyclones as well. So let's get straight into it. So number one, we have 3 high pressure cells. So if you have a look at screen, it says 3 big H's. One that is found in the interior of South Africa is what we called the Kalahari High. Then we find one that is sitting in the Atlantic Ocean, and that is called the South Atlantic High pressure cell, or the South Atlantic anticyclone. Then we find the one that is in Indian Ocean, and that one is called the South Indian high pressure cells. Now, what exactly do each of these 3 do for the climate of South Africa, or the weather of South Africa? The Kalahari High, as you can see what it says here, it produces clear skies and dry conditions within the interior during winter. Now, if you went back to last week's lesson, I spoke about something called convergence and divergence. And when I spoke about the word divergence, I spoke about air that descends. And as it's descending, it is heating up. So the area that is surrounding that particular high pressure cell will not experience any form of evaporation in terms of moisture. So it only brings about dryness. Then the South Atlantic high pressure cell. This causes southwestern winds to blow towards the land and is responsible for the very cold or dry conditions that we find along the western coast of South Africa. So, for example, I said to you last week that the cycle goes in an anti-clockwise direction. And because the Atlantic Ocean is a cold ocean, it's taking that stability and it's bringing it up into the western coast of South Africa. So that's why you don't find any type of rainfall in the summer months of the year in Cape Town, for example. You would only find it in winter. That's because of the high pressure cell. Then the high pressure cell that sits within the Indian Ocean, this causes northeasterly winds to blow towards the land. And it is responsible for rainy conditions along the eastern coast. Now, what happens with this particular cyclone, anticyclone, is that because it circulates in an anti-clockwise direction, number one. Number two, The ocean that is associated with this high pressure cell is a warm ocean. So it's going to pick up that moisture of that particular warm ocean. So even though it's a high pressure cell, it's going to override that dryness. Why? Because it's sitting above a very warm ocean. That evaporation continuously takes place all the time. So that's the big thing with these two cells here. The high pressure cell in the Atlantic Ocean, very dry conditions. Why? Because it's a cold ocean, and it takes over into the interior South Africa, dry conditions. Whereas the South Indian high pressure cell, it sits over a warm ocean and it takes over into the interior South Africa, rainy conditions. Right, so the most important thing again to remember, it is a high pressure system. That means that the pressure will start to increase towards the center of the actual high pressure cell. So if you see, it has 1014, 1016, 1018, and 1020. So when you get to the center, that is the highest pressure that is found. Within South Africa, it circulates in an anti-clockwise direction. Now, where exactly do we find these particular high pressure cells? They are found in what we call the temperate zone, which is here, right? So the sub-temperate zone, you would call them. Just where the Tropic of Capricorn and the Tropic of Cancer sit. So where those two regions sit, that's where you would find these particular high pressure cells. Now, the beauty part of this particular high pressure cells, not 1, 3, is that they move with what we call the intertropical convergence zone. Now, this particular intertropical convergence zone sits along the equator, but it moves up and down. Why? Because the Earth rotates on its own axis in an anti-clockwise direction and rotates around the sun. And because of the sunlight shining directly over the Tropic of Capricorn and the Tropic of Cancer, these particular high pressure cells move up and down with them. Now, within South Africa, your high pressure cells, that means that all three of those high pressure cells within the January months of the year would go further down and they would sit over the Tropic of Capricorn, which is at the bottom, right? So they move downwards. Whereas in the July months, so the winter months of the year, they move up and they sit above the Tropic of Cancer. So all three high pressure cells move higher up, right? So remember, they move together and they move with the intertropical convergence zone. Right, now, what happens with this particular high pressure system, especially the one within the interior, in the Kalahari, it creates what we called an inversion layer. Now, what exactly is the inversion layer? So before I go on, I'm just going to talk to you about the inversion layer. First of all, an inversion is a layer of air in the atmosphere in which temperature increases with height, preventing air below it from rising. So let's go through it one more time. A layer of air, actual air, within the atmosphere in which temperature increases with height, preventing air below it from rising. So it's a pocket of air that is found in the atmosphere. But as you go higher in terms of height, this particular pocket will prevent anything from the bottom from rising up. The inversion is lower than the escarpment in winter due to strong sinking air of the Kalahari High. Now remember, when I spoke to you about a high pressure cell, what did I say to you? Air converges on the upper parts of the atmosphere and it sinks down. So it diverges. So when it diverges, it then moves away, right? And this is what we're talking about here. That pocket of air forms here. Sorry, I don't know what happened. Sorry about that. In summer, the land heats up and the heat of the lower pressure forms where the Kalahari High is, which makes the inversion layer much, much higher than as opposed to your winter months. And I'm going to show you what exactly I mean. So let's go with the summer months of the year first before we do anything else, right? In summer, as you can see, this is the high pressure cell that is sitting here in the interior, on top here. And this particular inversion layer, that pocket of air, so we can see there, it moves up. Remember, what did I say to you? Your 3 high pressure cells move to sit over where the Tropic of Capricorn, which is at the bottom. So this pocket of air then kind of moves upwards in terms of the interior. So when we look at this part here where it says plateau, that is the escarpment of South Africa. So when we refer to the word escarpment, we refer to the Drakensberg Mountains. That's our escarpment. So that particular inversion layer goes higher. And what it allows to happen is that the warm air from the Indian Ocean can now pass over into the interior of South Africa that can bring about the rainfall. However, in the winter months of the year, that particular inversion layer drops below the escarpment. So way below the escarpment, that pocket of air starts to form. So that, remember I said to you, high pressure sub starts to sink down and it heats up. So you got hot air that is sitting before that particular inversion layer. Now, warm, moist air that rises now can't pass over because where's it going to go? That pocket of air is blocking it. So it prevents that moisture from entering into the interior. But there's one thing that happens. Remember, this is happening over the interior of South Africa. That means the inside of South Africa. But on the coastlines of South Africa, we still will experience rainfall within that area. Okay. So this is with regards to the Kalahari High. Now, we move on to what we call Berg winds and coastal lows. And together with these high pressure cells, we get certain types of winds that are associated or lows that form within the winter months of the year, especially Berg winds. So we're going to start off with the Berg wind. Now, a lot of children get confused when it comes to Berg wind. We also don't know what exactly it is. So the first thing that we need to know is a Berg wind is a hot, dry wind. Now, in order for this particular Berg wind to occur, 3 things need to happen for it to emerge. So the first thing that needs to emerge is a cold front that approaches from your western side of your of your country. The second thing that needs to form is your coastal low. If a coastal low is found in the winter months of the year on the eastern side of the country, we have a bit of a problem. Why? The coastal low circulates in a clockwise direction. So what it's actually doing, it's pulling air from the interior of South Africa off the coast. So we call that a fictional drag. It's taking all of that air, it's pulling it to the coastline, and it's turning the system. So it sucks in that warm, moist air. The third thing that needs to occur is your Kalahari High that needs to be present within the interior. Remember, I said to you, high pressure cell circulates in an anti-clockwise direction, and it brings about dry conditions. So if it's bringing about dry conditions within this particular region here, that air is going to start sinking. And remember, I said to you, it's a high pressure cell. As it starts to sink, it heats up. As it's heating up, it's going to heat up much quicker because now it's going to flow over a mountaintop. And that coastal low is found right here, which is going to pull that heat even more. So what happens? Warm, dry wind occurs. And this can obviously lead to wildfires, which is a very big problem. Also remember, in winter, everything within the interior of South Africa is very dry. So to catch a light is very, very easy as compared to your summer months of the year. So let's just speak about the role of the escarpment with regards to the Berg wind. So this is kind of like now a 3D image of what you would actually see. So let's look at it. So this is our plateau here, right? That is your subsiding air, this big blue arrow that is coming down. That's your subsiding air from your high pressure cell. As that particular high pressure cell subsides, that is creating your surface wind. That surface wind now is going to go down the escarpment. And as I said to you, as it's moving down the escarpment, it heats up. Your coastal low is going to pull it even more, and that becomes your hot, dry wind. So let's just read through it. The escarpment has a greater vertical elevation or height. Why? Because of that height. That's found here. Greater frictional drag as air moves down the escarpment. Remember I said to you, it pulls that particular wind with it, so it increases in temperature. Air has a greater vertical descent down the mountain. So remember, the Drakensberg mountain is plus minus 1,200 meters above sea level. So it's quite high. And we said that it starts to heat up. So it heats up for every 100 meters that it moves down, it heats up 1 degree. Right? So for every 100 meters that it moves down this particular mountain, it heats up 1 degree. So by the time it gets to the lower parts, it's quite hot in terms of its temperature. So what are the impacts of a Berg wind? So first of all, the impact is it causes wildfires. It destroys vegetation, plants, natural vegetation, obviously. Why? Because they dry up due to the hot, dry winds. It reduces biodiversity within that particular environment, and it declines ecosystems, and it disrupts food chains. Also, because of the high evaporation rate, the soil will eventually lose its content. Now, a typical exam question with regards to a Berg wind is what negative impacts will the Berg winds have? Now, it can have it in 2 different ways. Most questions would ask you with regards to a farmer, because obviously the Berg wind has a lot to do with your farmers. Or the second question that it could ask is with regards to an economic impact. Now, remember I spoke to you last week and I said to you, if an 8-mark question has to come in, it can ask you 3 things: economic, social, or environmental. If a question only specifies economic, you only talk about the GDP of the country or money of the country. If the question asks about the environment, you only speak about the natural environment, not infrastructure. Natural, something that is not man-made, that is there already. And then social would be regards to people, anything with regards to people. So within the social context, that's where you can bring in infrastructure. But you cannot bring in infrastructure if the question only stipulates anything to do with the environment. So most often we would say damaged crops. We would say decreasing crops would result in lower profits if it has to do with not only the economic impact, but social as well. Why? It's on farmers as well. Grazing land destroys. If you destroy grazing land, obviously your livestock is going to be affected. If your livestock is affected, it's either going to die, or it's going to be sold, or it's going to be non-profitable to you, right? Then destruction of natural vegetation can cause soil erosion. If anything happens to your soil does not become viable for you to plant any longer. You're going to then have a problem because you're going to spend more money trying to get your soil back again to its original state. Fires can destroy farm buildings, machinery, and your insurance costs will go skyrocketing again. Risk of fire can lead to higher premiums, like I said, for insurance, and eventually unemployment. Now, a trick thing that I teach my students in my classroom as well is that I say to them, especially with regards to the 8-mark question, put yourself into the position. So if the question asks you something about a farmer, pretend to be a farmer for 5 minutes. Okay, so it's affecting me negatively. How will it affect me as a farmer? What can I do as a farmer? So a question would either be suggest the impact or suggest strategies to combat the impact of it. So place yourself into the position. If it's asking you about the economy of South Africa, become a businessman for 5 minutes, or become the president of the country for 5 minutes. If they ask you, what can the government do? Right? So place yourself into the context. And I promise you, to answer the question will be extremely easy after that. Right. So, as I said, strategies: create fire breaks, erect lookout towers, build farm dams, create awareness. Also, another trick thing to learn is find common answers, especially for your 8-mark questions with regards to strategies. Education, create awareness. Those are 2 things that you can place in immediately and get your 2 marks. Right? So 2 marks with regards to create job opportunities. 2 marks for educating or skill development. That's another 2 marks. So it's already 4 marks out of your 8 marks. And as I said, place yourself into the position where you can come up with the other 2, which is very easy. Right. Another typical thing that they actually like asking within the exam, and we found this becoming a common trend, is that they ask you to draw a diagram of a Berg wing. So if you have to do that, please remember the following aspects are extremely important. You have to show the circulation of the high pressure cell, which is your Kalahari High. So remember, it must move in an anti-clockwise direction. You must say subsiding air. You must have just an outline of your escarpment and your arrows moving down the escarpment. You have to have descending air, and you have to say that it has a dry adiabatic lapse rate of 1 degree for every 100 meters that we descend down. We also have to say it has adiabatic heating. That means as it's coming down, it's heating up. And you have to have the last one, which is your coastal low. Right? Now, your coastal low. Where exactly is your coastal low and what is its role? Remember I said to you, it helps in terms of its pulling of your air from your interior. So coastal low is generally developed along your coastlines of South Africa. So that's one coastal low here that's found in Namibia, and here's the other one that is found here, right? So a low pressure cell that is found along the coast would be your definition of it. And the movement of air is channeled from the interior to the coast. A pressure gradient develops between the Kalahari in the interior and the coastal low. So this helps in terms of helping pull that particular air down. So a question could come out. What role does the coastal low play in the formation of a berg wind? And that would be your answer here. Right. The next one is line thunderstorms. Now, a line thunderstorm is very, very easy to understand if you understand your high pressure cells. I said this before, and I'm saying this again. If you know what a high pressure cell can do and a low pressure cell can do, in terms of its not only its characteristics, but its direction of movement, it is very easy to answer climatology. So here's your South Atlantic high. Here's your South Indian high. They both circulating in an anti-clockwise direction. But what did I say to you about the South Atlantic high? It sits over a cold ocean. So it's going to take with this, as it's moving to the interior, cool, dry, southwesterly winds. And it's going to take it into the interior. What is the South Indian high going to do? It's going to take in warm, moist, northeasterly winds into the interior. So this one's going to bring dry, and this one is going to bring warm and moist. And as they're coming into the interior of South Africa, remember they're moving in an anti-clockwise direction. So they bring in that way and they're coming in that way. These particular two fronts or air masses are going to hit each other. And they're going to form a front. Now remember when we spoke about the mid-latitude cyclone, we spoke about your westerly winds and your easterly winds. And when the two of them meet each other, they form a front between them. Why? Because one is cold and one is warm. So they form that front. And that front is called a moisture front. Now, when this particular moisture front happens, remember this is what happens. Your cold air is coming from interior and it's pushing it up. Cold moves faster and your hot is coming in also. But because the cold is going to start seeping its way underneath the hot, it's going to clash. And when that clash happens, a thunderstorm can occur because it's two masses of air hitting each other. So we get along this particular line, what we call the line thunderstorms. So all along this particular line, we'll get tremendous rainfall, torrential rainfall, lots and lots and lots of rain over the next 24 hours within that particular area. So if I look at it in terms of a side view, this is exactly what I see. I told you that cold air and I told you that warm air. Because of that very steep gradient that we find, we get those cumulonimbus clouds that form. And because those cumulonimbus clouds are forming on a massive scale, that's why we get your line thunderstorms, right? What is its impact? It provides moisture for dry soil. Your underground reserves obviously now get filled up because they increase. Floodwaters will clear pollution within the rivers. Nitrogen fixing from lightning will make soil fertile again. So as lightning strikes your soil, it causes nitrogen fixing in that particular soil. And that actually helps. Sorry. I have no idea what happened. Sorry. I got lost for a second. Sorry about that. Mac. When you have Mac, you kind of have issues when you have a Mac. iMessages pop up, everything else pops up. So yeah, sorry about that. As I was saying, the lightning can cause also fires, which is the bad part, and that can destroy natural vegetation as well as habitats. Heavy rainfall can also cause a wide spread of soil loss, meaning your soil will just sort of kind of run off. Okay. Please also note two definitions that they like asking is what exactly is a line thunderstorm and what exactly is a moisture front. So a line thunderstorm happens in a line on the eastern side where the moisture front forces each other. And your moisture front is the contact zone between your two air masses. Right. The next one that we look at is a synoptic weather chart. Now, this often comes in two ways. A synoptic weather chart can either be asked in your mapbook section, or it can be integrated mid-latitude cyclone, tropical cyclone, your anticyclones, or line thunderstorms, Berg winds. It can be integrated anywhere in your climatology section. Now, the thing that we found, especially from the June exam, is that your examiners have integrated questions. They have taken, for example, a mid-latitude cyclone, and they have mixed it with a Berg wind. They have mixed it with a line thunderstorm. So it's no longer questions in isolation, but they are now sort of condensing them together all into one question. So the most easiest way to actually understand a synoptic weather chart is just to know what everything actually stands for. So we're going to start from your isobars and we're going to move across the chart. So these are your isobars here. What does isobars mean? They are lines that join equal isobaric pressure across your map, right? If they are further apart from each other, which is this particular case here, that means that the winds are gentle winds. However, if your isobars are closer to each other, we get what we call a steep pressure gradient force, which means that your winds will be much stronger in this particular area. Then, if you have a look at this particular isobars, they are in a circular motion. So when you find your isobars in a circular drawing, you will know automatically that that could be a pressure cell, either high pressure cell or a low pressure cell. Right, as we come in, we need to have a look at these particular two lines. The one with triangles are your cold fronts. The one with the semicircles, your warm front. And the one that has both is your occluded front. It has not only the cold, but it has the warm as well. Right. As you're coming in, they'll be fine. There's a coastal low there. If you find that there's a high pressure cell that is sitting over the interior, that tells you that it's a Kalahari High. If there is an L within the interior, that will tell you it is a thermal low. You also will need to be able to recognize where your South Indian high pressure cell is and where your South Atlantic high pressure cell is. Right, so don't forget those two there. A question would typically ask you, if they give you a synoptic chart, what is the season? Very easy to distinguish. If it is winter, your interior would have a Kalahari High, number one. It would have much lower temperatures. It would have rainfall that is found on the western coast of South Africa, and the presence of a mid-latitude cyclone. If it's the summer months of the year, you'd find that there would be a thermal low within the interior South Africa. You'd find lots of rainfall on the eastern half of the country. You would find also temperatures are quite high, and you would not find the mid-latitude cyclone. You would instead be able to spot a tropical cyclone. Okay. How exactly to read a particular weather station? It's very, very easy. So I'm going to start with it very slowly. The circle represents your cloud cover, whether it's a quarter, whether it's a half, whether it's 3/4, or whether it's overcast. Please, children, do not make this mistake. It does not mean that if the entire circle is covered and it's overcast, it is going to rain. It will just suggest to you the cloud cover. That is all. Only cloud cover. Then, the number that we find on the top will produce to us the temperature, and the number that is found at the bottom is the dew point temperature. Now, if the dew point temperature is very close to the actual temperature, that's when it is going to rain. So, what exactly is the dew point temperature? It is how much the actual atmosphere of that particular region is saturated. So the closer the number to the actual temperature, that's when it will rain. But say, for instance, the temperature is 20, but the dew point temperature was only 10. It was still overcast. There is a very unlikely event that that particular area is going to experience rain. We don't necessarily find a weather symbol between your temperature and your dew point temperature, but because some examiners like to include this, you need to know the different symbols. So in this particular case, it's just a dot, and the dot would suggest rain. If it had an asterisk, it would suggest snow. 3 lines, it would be fog. A colon or semicolon, it would be drizzle. Showers would be an upside down triangle, and thunderstorms would look like an R symbol. Then the line that is coming out of your weather station, just that particular line there, would tell you your wind direction, northeast, southwest, whichever. In this particular case, it is a southeasterly wind. That would suggest to you your wind direction. Then the 2 lines that are joined on that particular line will give you your wind speed. The shorter one would be 5 knots. The longer one would be 10 knots. If they have both, 15, right? And if it just has a sort of an angle one, like this particular one here, it would only be 5 knots. Also remember that how certain isobaric characteristics would look like. If it is a low pressure cell and it is sort of going in a oblong way, we call that a throw. And if it is a high pressure cell and it's also doing the exact same thing, it is sort of going in an oblong way, we call that a ridge. So it's an elongated piece of either high pressure or low pressure. The next one that we look at is your valley climates. Now, valley climates are very easy to actually understand. There are 2 types of climates. One is called an anabatic wind, and one is called a katabatic wind. Now, the easiest way to remember this, well, lots of people actually think of various different ways to remember. A comes before K, so day comes before night. That's one way to remember it. The second way to remember it is katabatic, refers to cat, first 3 letters, cat. Cats generally prey at night. So they come out during the nighttime. So when we refer to cats, we're not referring to your domestic cat. We're referring to a lion, tiger, those type of cats, right? So catabatic would be nighttime. Anabatic would be daytime. So what happens during the day? The slopes and the air above them is heated because of the sun. So you would find that the air on your slopes would actually rise. Why? Because they are lens dense, and so they would rise up the slopes, and they form what we call anabatic winds. However, during the night, it's colder, and dense air subsides down the valley slopes, and they form what we call catabatic winds. But with the catabatic winds, we also get a thermal belt that is formed, or an inversion layer that is formed within that particular valley there. Okay. Let's go into the inversion of it. So inversions form when normal patterns of air temperature is reversed. So because of that cold air that sinks down the slope, and cold air gets trapped down at the valley floor, it forms that inversion layer. Now, most often this inversion layer could either be two things. It could be just a natural pocket of air that descends down, or it could be hot trapped air from pollution that can actually cause this particular inversion layer. So there's two ways of that inversion layer being created. And remember, because the temperature increases with altitudes, as you're going up higher the slopes, that inversion layer develops there. Most often, thermal layer develops in your winter months of the year. So when your cold air descends, and then you get that warm trapped air, and then you get more colder air, you find that it's extremely, extremely cold, and frost develops then on the valley floor at the bottom. Becomes a big problem, especially if a farmer decides that he needs to plant crops within this particular region. Sorry. So, as I said to you, that frost pocket there actually forms. Now, what can be the negative effects of this particular inversion on humans or on the environment, for instance? Cold temperatures are found within this particular valley area. Non-frost resistant crops can become destroyed, which is a big problem. The inversion then traps all that pollution that is found within this particular area, and that will give us respiratory problems. It also creates fog within this region, and that obviously reduces visibility. People prefer to build houses on the northern facing slope. So for example, if we stay in South Africa, this would be your northern facing slope, and they would tend to build their houses higher up on the actual inversion layer because it's warmer, right? So eventually they settle within that particular thermal belt. However, vineyards are planted on the warmer northern facing slope. So if you are a farmer and you obviously within the Western Cape region, you would then place your vineyards more on this particular slope here as opposed to this one, because this one falls in the shadow. Becomes a problem as well. Frost-resistant crops could be planted within this particular frost pocket, and crops that are sensitive to frost will be placed higher up or higher up there. Last one, the last section for this particular day is your city climates. Now, city climates are extremely easy to understand, especially if you think about a city and you think about a rural area. Within a city, it is much warmer, whereas in a rural area, it is much cooler. Why? Within an urban area, we have artificial surfaces, tar roads, we have high-rise buildings, we have lots and lots of people. We have motor cars, we have lack of vegetation, air conditioners, large dark surface, and lots of pollution. Whereas in the rural area, we have vegetation and dense vegetation. We have not that much of pollution. We have few or no industries, less people, fewer cars, and small heat absorbing surfaces. Why? Because most of the area is covered in vegetation. So obviously, rural area will be much more cooler as opposed to your urban area. Now, if you have a look at this particular thermal stat that is found in this diagram, it shows you that your CBD, because of those high-rise buildings, will have a very high temperature. But as those buildings sort of now get less and less tall, I would say, within your suburban areas, the temperature starts to drop. And then as you move to the rural area, your temperature would drop significantly. So remember, your temperature in a rural area is much cooler. Your cloud cover would be less. Why? Because there isn't that much of heat within your rural area. The precipitation, or the rainfall, if you want to say, there would be less rain in a rural area as opposed to an urban area. And your relative humidity would be higher. So that means you generally won't get, your dew point temperature won't reach your actual temperature itself, right, within a rural area. Your wind speed is much higher because there's less things to hit on, whereas within an urban area, there's more turbulence. So you find that your wind speed is less. Fog, more fog within your urban area, less fog within your rural area. So we get then what we call an urban heat island. And an urban heat island means that your highest temperatures are found within your CBD of that particular profile. And as you move, as I said, away from your CBD, it becomes lower and lower in terms of the temperature. Right, now, remember the following aspects, especially when we are talking about an urban area. We find, let's start with this one here. Rising warm air can cause thunderstorms, releasing latent heat. So as the evaporation is taking place and it's moving to form clouds, before it reaches the cloud formation, the change from the one phase to the next phase, so from your water droplets to your water vapor or vice versa, heat becomes released, and that's called latent heat, so more heat. The second thing, buildings store heat and then releases it during the nighttime. High-rise buildings can reduce wind speed and it can then warm air much quicker. As you're coming down, limited impact in suburbs due to the low density. So we don't have that much of impact in terms of the temperature increase in your suburbs. Traffic congestion causes major temperature increase. Your parks, however, decrease your temperature. Then people itself, so the concentration of people. If lots of people are in a room, what happens? The room becomes hot, becomes claustrophobic. Exactly the same thing. People inhale oxygen, exhale carbon dioxide, right? So we also release some forms of methane from our, okay, let's not go there, but do you know what I mean? Industries and offices release heat as well, especially from the air conditioners. Remember, air conditioners from the outside would produce heat, so much more heat. Rivers can cool down any areas by means of evaporation. Central heating in buildings increase the temperature, and then drains remove rain very quickly. So there isn't a lot of time for water to sit to cool down that area, right? So it becomes a bigger problem. Now, the next one that we look at is a pollution dome. So remember, very big difference between an urban
And we seem to have lost Alia in the last few minutes of the segment. And that's all thanks to load shedding. But I think she managed to cover quite a bit in today's lesson. And we look forward to having her back with us again for her next lesson. So for now, we wrap up today's session of the Matric Revision on Geography from myself, Conita Kamara. But you farewell. Assalamu alaikum wa rahmatullahi wa barakatuh.